So dear all, let us see about the course power system protection and switchgear. To start with the protection and switchgear power system, we know that the power system plays a vital role in the electrical systems. So when considering about this power system, the main factor to be considered is protection and switchgear. So here in this class, we let us see about the protection principle and then what are the switchgear that can be adapted for the power system components. Okay, so this is like the electrical power systems. We have like for 6 terminals, starting with the terminal number 1, they call like generation, so generating station. It is given back to the second station is nothing but the transmission. So as we all know that generation, transmission and distribution, these 3 are the main key factors in your power systems, electric power systems. So start with, we have this generating station number 1. So the generation may be like from hydro or thermal, or maybe like we can say that in kinds of your ideal combination of these hybrid modes. And then it is given back to the second unit. So the second unit is nothing but the transmission unit. So here 11 kV generators can be stepped up in the case of your step up transmission, and then this energy can be travels towards the third station, that is called your third station, is nothing but the transmission where the power is needed. Okay, and then again I want to give back to the substation. So I want to control this fourth one is nothing but we have to step down those values. So this can be done by the unit number 4. So that can be voltage is decreased or step down at the substation. We can call as in this station as fourth station. It can be decreased or it can be increased. And then after that it is given back to the fifth terminal, that is fifth station. I can say that it is like distributor power line. So from here the power will be distributed to industries or maybe like any business, or it may be like for residential purposes. So the final is nothing but the sixth one is nothing but the residential or maybe like home or business. So this is like the entire structure of your electric power system, starting with your generating station, and then we are having the transmission station, and then finally the 5 and 6 you can say that is like a distribution. So this slide shows the single line diagram of the entire content, starting with the generator, and then we have these substation components like the transformers. I can say that is like power system components. We can start with transformer, bus, the transmission line again is like a bus, and then it can be stepped down where transformer is given back to the appliances. It can be like it can be like industry or maybe like domestic applications. So this figure shows the entire content in the term of a single line diagram. So these are the protection symbols that is normally used in the power system. We can say that starting with the 2 winding transformer. So this is like a 2 winding transformer. This symbol represents the current transformer, and then this symbol represents 2 winding transformer. Similarly with respect to the voltage transformer, and then this symbol, that is round symbols, denotes like generators, and then this symbol stores the capacitor. So these are the various symbols that is normally adapted in protection systems. So here let us see this. Say for example, this is like an one. We are having like, we can see that almost in all domestic appliances we can see this. This is a 3-pin holder. Again here we have like 3 pins. So one is like a projected one, and the another one it's having like the broader section when compared to these 2 terminals. So why? What is the reason? So why these can be designed like very high, maybe like the area will be very high compared with these 2, and then it is also projecting. So here why it is given like it's nothing but it is like the earthing component. So when you are getting like high voltages or maybe like switching over voltages, so these can be given back, taken through these projecting things, and then it can be earthed back and is given back to the ground. So first contact of your voltage may be like, the first contact should be your projecting rod. That may be like the topmost. I can say that this is like a topmost one. So this is like the first one, it can be projected in such a way. So I can say that the formula for this one is, we know that R equal to rho L by A. Okay. So I can say that this area of this cross section of this particular conductor is very high. So when area is very high, then the resistance will be very less. So I can say that when the resistance is very less, we know that I equal to V by R. Okay. So when the resistance is low, then automatically the current value will be very high. So when you are getting like the switching over voltage, or you are getting abnormal current, so this abnormal current will be taken by this conductor and is given back to the ground. So this current value will be very high, the resistance value will be raised. So based on this mathematical formula, I can say that the resistance value will be decreased and then the current will be increased. So the first contact of your earthing will be making a contact of the touch, and then when you are getting abnormal current, when the high current will be coming back, it is taken by this conductor and it is given back to the ground. So that we can say that this is like a projecting rod. This is a projecting, and then the area of the size is very high compared to these two terminals. These two terminals are called like a phase and neutral. So this is like an entry point of questions they may ask in your interview when you are going for the interview. Why these three conductors are in different shapes? Okay. Okay, so these are the next. Let us see about the primary equipments and then the components that is mainly involved in the power system. As we are studying about the protection switchgear, so these are the main primary equipments. So first I can say that this will be grounding. So grounding is very important, and you see almost all your equipment in almost all your home appliances. We can say that the grounding plays a vital role. So why it is main? The grounding is main. Grounding or earthing is main is to maintain, to operate and maintain the equipment safely. Also it can be useful for the safeguard for the human beings handling these power system components. So second one is nothing but the arresters. So when I am getting like the over voltages, I can say that over voltage can be classified into two types. One is called your lightning over voltages, another is nothing but your switching over voltage. So when I am getting like lightning over voltages, the equipment, the substation component should be equipped, or it can be protected. So these can be protected by means of your surge arresters, or I can say that lightning arrestor. So the third one is nothing but the switchgear components. So what will be this switchgear? The switchgear is nothing but the integrated components. I can say that it can be switch or can be meters, and then have the controlling circuit. So this switchgear is nothing but a combination of these three components: switch, meters, and your control circuits. Then the fourth one is nothing but reactors. So why these reactors can be used? Reactors can be used to limit the fault current. So when I am getting like the fault current, so I can use these reactors, or to compensate for your charge currents. And then we have this potential transformer and current transformer. Here I given like voltage VT and CT. So what is the use of these transformers? I can say that the potential transformers and current transformers are mainly used to measure the value of voltage and the value of current. So in power system, if we see that 11 kV or maybe like 100 kV, we are not having these normal voltage meters available. So for that reason, we need this transformer which can be step down your value from 11 kV to some 0 to 400 volts. So for that, we are having a combination of this VT and CT. And then next one, regulators. Of course, we can see that this regulator plays a vital role. If you see this in household activities, I can say that these regulators plays a vital role. So it can provide like stable voltage and stable current, and then to maintain the phase angle is very important. So these are the primary equipments, and then the components involved in your power system components. Then next question: why a system needs a protection? Okay, so as we know that we should run our system in a fault-free system. Okay, if we are getting like any kinds of fault, it will entirely spoil our entire power system. So for that reason, we need there is no fault-free system. Okay, so we have to provide a safety of proportion. That is very, very important. So for that reason, we need a protection. So usually the faults may be occurred mainly because of your breakdown of your insulation. This can be like the overcurrent, over voltage, or maybe like lightning. So the two kinds of over voltages are called, I can say that, internal over voltages and external over voltages. So internal over voltage is mainly because of your switching over voltage. When I switch on your circuit, any circuit, say for example I am having this circuit, I can switch off this circuit. So when I am getting like switching on and off, I can say that there will be a transient over voltage will be present. And then the second one is nothing but the external over voltage, which is nothing but the lightning over voltages, which is normally occurs during your external. So that's why they call that external over voltages. Then what is this switchgear? So switchgear, as I already told, that it is a combination of your switches or can be fuses or maybe like the circuit breakers. So it's normally used to control and protect our system, electric power system. So all your electrical equipment are costly. So in order to have this protection about your entire equipments, we need this kind of switchgear combination. So switchgear is normally like the switches, fuses or maybe circuit breaker. So here I can show you like one small thing which I can say this can be considered as a fuse. You can see that in almost all the cases in the electronic fuses. So the fuses plays a vital role. Okay, so like you are when I getting like the current rating. Say for example, I am having a motor of current rating of like 12 amps. I can put like the fuse of 122% of this total current value. So 120% of your 12. It can be like maybe like 100%. I can say that maybe like 50 amps. So these fuses when I getting like over current, it can be blown down. Okay. And then so here this is the main thing, like as we are talking about the relay. Relay plays a vital role. Relay is the backbone of your entire power systems. So when the relay will be operating, so this relay plays a vital role. Here I can take like the best example is merged bias differential relay. Okay, so here I am having this line. We have like two circuit breakers, and then this CT1 and CT2 represents the current transformer 1 and current transformer 2. Here, suppose I am getting a fault in any of the line between your two points, like between your CT1 and CT2. Okay, so under normal condition, the current flowing between these two current transformers are equal. I can say that there will be a zero current flow through your relay coils. That is like a normal condition. So when I getting like abnormal condition, when we are getting like abnormal condition, when I getting like a fault, so I can consider there a fault between your two lines, between your 2 points, between CT1 and CT1. So there will be an abnormal current. If we see that, if you are taking the calculation of these two currents, say for example this is I1, this is like I2. Okay, so I can say that this is like I1, this is like I2. Okay, so when I am getting like abnormal conditions, I can say that there will be a differential current will be keep on flowing. So when there will be a differential current, when I am getting a fault. So when I am getting a fault, I can say that there will be a differential current will be keep on flowing. That is the differential current is nothing but I1 minus I2. So this current will make the relay to operate. And then it's given alarm to the circuit breaker to open the circuit breaker. So this fault can be rectified. So this is the one of the scheme. So here I can say that is one of the prototype that can be made. So here you can see that this may be like your transmission line. So this red tape you consider like your fault line. So here I can consider like two transformers CT1 and CT2. Here I am having this relay coil. So when the fault occurs, so there will be a differential current will be keep on flowing between the two parts of your current transformer. So this differential current will operate your relay operating coil. So now the relay will be put into operations. When I am getting these kinds of your fault that can be occur between the 2 points of your things. So this current transfer will sense the current. When you are getting like abnormal current, it can be sensed by means of this current transformer, and then it is given back to the relay. So next important is nothing but your circuit breaker. So as we know that circuit breaker plays a vital role in your protection switchgear. So circuit breaker can make or break a circuit either manually or automatically under conditions. So what are the conditions? I can say that no load condition, full load condition and short circuit condition. So the circuit breaker should be having capable of breaking this circuit by means of automatic, can be like an automatic, can be like a manual. Okay, so here I can say that when I am getting like fault conditions or when I am getting like abnormal condition, then the circuit breaker should be open. So it's like a normal switch. Okay, so it can be sensed by means of any abnormal by means of any remote controls or something, and I am getting like kind of things. I can say that this circuit breaker plays a vital role. Okay, so here let us see about the one of the most commonly used circuit breaker, that is like SF6 circuit breaker. I can say that sulfur hexafluoride circuit breaker. So here this kind of, why they call like SF6 circuit breaker is nothing but the SF6 is normally used as an arc interrupting medium. So why you are using like SF6? Why not different gases? I can say that SF6 has a high dielectric strength. It has a high dielectric strength, which is an important quality of matter to be considered. And then similarly, it has a high rate of rise of dielectric strength after your arc extensions. So why the advantages when compared with your another kind of circuit breaker, I can say that it can be superior arc quenching property. Arc quenching property of the circuit breaker is very high, so that it have like very short arcing time, and then they, of course we know that dielectric strength of SF6 is 2 to 3 times of that arc. Okay, and then it gives like noiseless operation due to its closed circuit. I can say that it provides like a noiseless operation, and then entire thing it will be inside your kinds of enclosure. So when having this enclosure type, then there will be no moisture problem will be there, and then there is no risk of fire, as we know that SF6 is non-inflammable things. Okay, I can show you one video. Okay. So this is like the basics of any circuit breaker. If we see this circuit breaker here, I will tell you the operation of this circuit breaker. So here we have like two contacts. One is called your fixed contact, another is nothing but your moving contact. Okay, so under normal condition, this fixed contact and moving contact both will be closed. It can be closed. So when you are getting like abnormal condition, when you are getting like fault current, this moving contact will be moved. So when you are getting like the relay operation, so then the relay is nothing but the brain of your power system. When the relay gives a command to the circuit breaker, then the moving contact will be moved away from your fixed contact, and then the SF gas will be coming back through this chamber. So here I can say that this, when you are getting like when there is a movement between your fixed contact and moving contact, there will be an arc will be generated. So in order to quench your arc, they are flowing this SF6. So the SF gas will be entering, and then this gas having high dielectric strength will make your arc to be quenched. So the arc will be extinguished. So this is the basic idea behind your circuit breaker. We see that almost all the circuit breaker, the operation will be like this. So here we are having a moving contact, and then it's called a fixed contact. So the SF gas will be inside, allowed inside, then the moving contact will be keep on moving. So this is an example, the video. Okay, so we are seeing like the circuit breaker operation. This is the basic circuit breaker SF6, and then so let me move on this whatever we have studied in like kind of the importance, nothing but we need this something like the people are expecting some gate questions, or maybe like when they are going for the competitive examinations. So this is like one of the gate question they ask. The inductance and capacitance of a power system network up to the circuit breaker location are 1 Henry and 0.01 Henry respectively. Find the value of shunt resistance across the circuit breaker required for critical damping of the restriking voltage. Okay, so they are given this value is C equal to 0.001 microfarad, that is the capacitance, and then the L is equal to 1 Henry, and then we know that the formula for the critical resistance R equal to 1 by 2 root L by C. So you can substitute this value. So L as 1 Henry, and then your capacitance as 0.01 into 10 power minus 6. So if you are taking the calculation, I can find out this value as 5 kilo. Okay. So this is like a basic question. So you can able to find out the critical resistance of any kind of your value of shunt resistance we can add across your circuit breakers. This is like the second question. So this is one of the competitive question. I can say that this is also one of the gate question. So in a 230 or a 132 kilowatt system, the series inductance up to the point of the circuit breaker location is 50 millihenry. The shunt capacitance at the circuit breaker terminal is 0.05 microfarad. The critical value of resistance in ohms required to be connected across the circuit breaker contacts, which will give no transients oscillations. So we have to find the critical value of resistance. Again the same formula, R equal to 1 by 2 root L by C. So here they given the L value. So what is the L value? I can say that the inductance value as 50 millihenry. So 15 to 10 power minus 3, I can substitute instead of L, I can substitute at 15 to 10 power minus 3. And then instead of C value, so C value they given as 0.05 microfarad. So I can say that 0.05 microfarad. So we can able to find out this L value. So L is nothing but 50 millihenry. So 15 into 10 power minus 3, 10 power minus 3 Henry. And then the capacitance. The capacitance they given as 0.05 microfarad. So 0.05 to 10 power minus 3, minus 6 farad. We can substitute these two. So we can find out the R value is equal to 1 by 2 root L by C. Okay, so I can substitute this value. So finally I can substitute this value. So I can get like 1 by 2 root 15 to 10 power minus 3 divided by 0.05 into 10 power minus 6. So I can get like 1 into 10 power 3 divided by 2. So the final value is 1 into 10 power 3 by 2. Okay. So once again I can repeat that this is like an important gate question. I can say that in a 132 kilovolt systems, the series resistance up to the point is they given the series resistance inductance value and then the capacitance value. So we have to find the critical resistance. The formula is R equal to 1 by 2 root L by C. You can just substitute this L and C, I can find out this value. So this is the critical resistance they are using. Okay, so we will move on to the next question. So here also like the three sections of the circuit breaker they are given. Three sections of a feeder are provided the circuit breaker 1, 2, 3, 4, 5 and 6 respectively. So we have to find the fault. So say for example the fault is occurring at PDU1. So this is like our feeder. I can say that the three sections. I can say that 1, 2 and then 3. Okay, so this is like a generating station. We can have this circuit breaker, and then this is like a bus bar. I can say that I can provide like three sections. So first we have to classify like three sections 1, 2 and 3. So here they are saying this fault is occur this such. So for example here is a fault. Okay. So here first which circuit breaker should be operated? I can say that the circuit breaker 1, I mean like circuit breaker 5 should be operated first. Okay, we should be open so that we can say that this section has been like we can be disconnected. So here the sequence of this is nothing but the first breaker should be open as CB5. Okay, so they may ask the question which circuit breaker should be opened first. So as a primary protection, this like this CB5 should be opened first. Okay. So this. Okay, so that's all. Thank you.